Let's look at the next problem. The next problem that we have now on our hands is intersection of two linked lists. Now, as you might deduce from the name of the question, what you have to do is you have to see where two linked lists are intersecting. But which linked list and what sort of intersection? So let's read the question. Given the heads of two singly linked lists, head A and head B, so we have two linked lists. This one is 1 and this one is 2. This one is A, this one is B. Return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. So there are like three possibilities. Not three, but two possibilities. The first possibility is that those two linked lists would be intersecting. Then you have to return the node where they are intersecting, the first intersecting node. And if they are not intersecting, then you have to return null. Okay. Um, let's see. So this is the linked lists that you are given. This is 41845, the linked list A, and 561,845, the linked list B. So the issue in this problem, the major issue in this problem is that the two linked lists can be different also. They can be same also, but they can also be different. So you'll have so basically a normal traversal thing would not work here. You can't just keep on matching the pointers, the nodes, and say this is intersecting and this one is not, because it may be possible that you reach the intersection point uh, earlier in one of the linked lists, and you reach later in the second one. So let's see. So in this example, 41845, and and okay, my bad. And 561, right? Okay, so this is the linked list. So how do we solve this? So there are like three ways to solve this. First would be a brute force, where we'll use a data structure to store uh, the nodes of one of the linked lists, and we'll match. We will basically find in that data structure if the nodes of second linked list are there, and if they are, if like the first one which is present in that data structure, and I'm also traversing on the linked list, if they match, simply return that node. If you're not able to find um, any node and the traversal on the second linked list is complete, just return null. So let's see. So in this example, what we can do is we can take an unordered map. So what you will store is that, for say that you are here, you are traversing through this linked list, you store, okay, let me just check one thing. 418, 418, okay, 4 is occurring twice, that is correct. Okay. So the issue you will observe in this method is that you will see this is same as this one and this one is same as this one. So what you need to store is not just the value, but the node itself. So that will help you differentiate between this 4 and that 4 and this one and that one. Okay, so I'll store nodes corresponding to booleans, or say number, let's say 1. So I'll store 4 corresponding to 1. I'll store 1 corresponding to 1. I'll store 8 corresponding to 1. I'll store 4 corresponding to 1. And I'll again store 5 corresponding to 1. Okay. Now I'll traverse over this linked list and I'll see if like I find any of these nodes in this data structure, which is like the previous linked list. So I look at 5. Yep, it is present. But since it's not the same node, so this will not match in this case, even if you will try to find this, but this node will not match. So we'll go to 6. This just doesn't match. It's not there in the data structure. One, like the value matches, but the nodes are different. So this will also not give me a yes when I will try to find it in the map. And for 8, the nodes match. So this is your answer, and at this point you will simply return the number. So say this like did not intersect, you are this is null. And after 1 you go to null. So this simply means that you have traversed through that second array and you have still have not found any node which matches to the nodes present in the map data structure. So you will conclude that these two linked lists do not intersect anywhere. Okay, so let's try to code this problem. So let's see. Okay. So in this question, what I'm doing is O of n plus O of m would be the time complexity, because we are like traversing through the first linked list, and then second linked list, assuming the first one has the sizes and the second one has the sizes m. The time complexity would be O of n plus O of m, um, and the space complexity would be O of n, um, or whichever whichever linked list I'm storing, that linked list size. So let's try again an ordered map, which will have is node and a boolean or integer. Let's say integer in this case. Let's say m. So what you will do is, first of all, create a temporary variable which will point to head a, and it's true uh, temp one while temp1 exists. What you do is, you keep moving and storing. So m of temp1 is equal to 1, and temp1 is equal to temp1 connect. Okay. So you're moving and you're storing also. Now after you have stored this, you will take another temp variable, but this one would store head of b, and same thing, you'll traverse over this the second linked list like this, and you will check if it is present in the map or not. Okay, and if you're able to find it, just return that node. If not, just keep on moving. And this will work till time exists. And if you're not able to find anything, just return null. Okay, let's see if this works or not. Let's try to run it. Okay, so we have a typo over here. Okay, this got accepted. Okay, so this worked, but this is like a brute solution and this will not hold up in an interview. So let's go see an optimized approach. Okay, so let's try to think again. We have this 41845. Okay. So the second method, um, which is like a more optimized, because it does not use any space, is what you can do is simply calculate the lengths of both these linked lists. So you take a temporary variable here. So you traverse one, two, three, four, five. So the length of first linked list would be five, and you traverse through the second linked list one, two, three, four, five, six, six. So the difference here is six minus five is one, and we know that the second linked list is greater. Um, so in that case, what you will do is in the on the on the greater one, you will move whatever steps came in this difference thing. So one step. So I'll just move one step. So head B will go over here, head A will remain over here. Now we will start comparing. Are they equal? Nope, they are not equal. Are they equal? No, they are not equal. Are they equal? Yep, they are equal. So this will return. Okay, let's try to code this. So basically, what you're simply doing is you are just calculating which one is a like longer linked list and the difference between the lengths of these two. And on the longer one, you just move that many steps uh, that you came to know from the difference thing. Let's try to code this. Okay, let's find the lengths. Okay, so first what we'll do is let's take list node L1 is equal to not L1 but like temp one would be head A, list node temp2 head B, L1 L2. Okay, while temp1 exists, just keep moving the temp and subsequently increasing the length, and repeat the same thing for. So we have both lengths, right? So what we can do is if L1 is more than L2, which basically means that the first one is longer, what you would do is simply let's move it till the difference becomes zero. After you have like aligned them, both the linked lists, simply while a is not equal to head b, just uh, if head a is equal to head b, then return head a. Else what you do is you just keep moving. Okay, and after everything is finished, just return head a. Okay, and this condition also will be checked while head a exists and head b exists. Okay, if this is if like any of this ends, you just simply return null because it simply means that they are not intersectable. Let's try to run this now. Head, okay, the name is not correct. So this will be head of a. This will okay. So intersection value is 8. This is giving me no intersection. Okay, that does not make any sense. If head A is not equal to head B, okay, now let's just remove this condition also. This condition. Okay. So if any one of them is null, then you stop it. Difference L2 minus L1, which is correct. But difference minus minus at B next. Okay, my bad. Here you need this. It's got accepted now. Let's see if this works. Yep, this works like charm. So first you do the first thing that you did was O of n, and the first was O of n for traversing, O of n for traversing, and then what you did was basically traversed the whichever was the longer. So O of whichever n or m was longer. So this would be um, time complexity. The space complexity would be of 1 because you are not using any space. Okay, so okay, so this is optimized, but can you further optimize this? Is there any other way to like make this more optimized? Yep, there is one algorithm. So let's say we have 41845. 41845. Okay, this is 4, this is 5, this is 561. 6 1. Okay, so what you have to do in this case, uh so basically what is the issue is this non-alignment, such that this one first goes through three nodes and then reaches intersection, and this one has two nodes and then intersection. So there's this algorithm which basically get rid of this extra length. How? Let's see. So what you do is you have one over here. Let's say there is a pointer which is called one, and there is a pointer which is called two. Okay. So what you do is you start from here. You keep on moving till this first pointer is not equal to second pointer. Okay. So you move here, 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 here. Now the question arises: what happens when uh, you reach null? So what happens is, if any one of the nodes, so we know the case where if both the nodes are same, you return that node because that is intersection. But if one of them reaches null, then you replace it. Suppose the first pointer is null, so you point this to the head of this second linked list, the opposite linked list. Okay, so the one will go over here now, the two is over here. Okay, and what will happen now is, um, what will happen now is that we'll have one here. Okay, so basically they will go alternative. So when the one will go over here, two will go over here, and since it is null, it will go to the opposite one, which is two. Now you will see that they are aligned, right? So this is what is exactly happening is, so they are like sort of balancing each other out. They are balancing the difference when they reach null. Now from here on, you can simply check: is this equal to this? Nope. Is this equal to this? Yup, this is the intersection. So here it is answer. Let's try to go to this algorithm. So in this one, you are traversing off, and basically you are traversing off and sometimes off and sometimes. So the kind of off and plus off and let's try to go to this. So what you need to do first of all is take two pointers. And till the time they are not equal, you keep on moving them, in the sense that let's move temp 1. Now you'll check if so you had first checked on in the while loop itself, were they equal? They were not. So if they are not equal, you will enter this loop and you will move it one time, then you will again check, are temp 1 equal to temp 2? If yes, then just return that node. You can return either the temp 1 or temp 2. And in the case where any one of them reaches null, you just point it to the opposite linked list. So if the temp 1 was initially pointing to first linked list, let's link let's point this to 2. Okay, so the temp 1 will now point to head B. Okay, and if temp 2 is null, is has reached null, let's populate this with head A. Okay, so at the end of all this, if you are um, if you're not able to find uh, any point where like they are matching, uh, You can simply return null. So so how this will like exit the while loop when both of them will be same. So we have already covered this in this case where temp1 is equal to temp2. So what you will do instead of returning null, suppose on the uh, first node itself they are like same. So what you can do is simply return any one of them node, because say we have reached null in that case where both where the linked lists are not intersecting. So in that case they will reach a point where both of them will be equal to null. So in that case the while loop will end and will come out. So in that case also we'll have to return null, but in the case where the first node is the intersection, you will also have to return that intersection. So to satisfy both these conditions, you can simply return the temp1. Okay, let's see. Okay, this worked. Okay, this worked like a charm. Let's check if this is available. Mm, often. So this like for some reason gives often every time. But like to be specific, this is ofn plus ofm because we are traversing both the linked lists. But technically like we balance each other out, so we can say ofn, but better time complexity would be ofn plus ofm, and the space complexity is of1, which was not there in the first example. So this is like the optimized version of this problem. That's all for this video. Thank you.